Sometimes we're not given the polynomial function, but we're asked to write a polynomial function given roots or zeros of the function. And so what we're going to do is go backwards from what we did before. What you want to do is think about if these are the roots of the functions, this once again represents the x-intercepts. Roots, x-intercepts, and zeros are all the same thing in effect. So that means whatever this thing is doing, it's crossing the x-axis at -2, 1, and 3, and so maybe it's doing something like this. But there's lots of other ways it could touch those points as well. It could have started up and worked its way down, but we're going to go with the most simple one because notice it doesn't say write all the polynomial functions. It says write a polynomial function with these roots. So we're going to assume they just happen each one time and write the polynomial function that way. So if you think about when we went backwards and found the zeros of the function or the roots of the function given the polynomial, we always tried to factor it first. And so we're just going to go backwards, and if we put these back into factors, think about what they would have looked like before they became -2, 1, and 3. And so basically you go x minus -2 or x plus 2, and you can just think of this will always look the opposite of the 0. And then x minus 1 would have given you the 0, 1, and x minus 3 would have solved to give you the answer +3. So these numbers that you put next to the x should always look opposite of what they look like as roots or zeros. And then, because it says function, we either should put an f of x in front, or you can also just simply put a y in front. If all they said was just write a polynomial function and they were okay with you leaving it in factored form, then we could stop there. But if they say anything about writing it in standard form, we have to go a step further, which is multiply all these parentheses and get something without parentheses. So let's work on that on the next page. So to get it out of factored form and into standard form, you want to multiply, and you can really only multiply 2 binomials at a time. So we're just going to take the first 2 and FOIL them. First, outside, inside, and then last times last. And then there's still an x minus 3 here, so I would write it again just so you don't forget about it. Then these two terms are like terms, so we should always simplify it before we try to multiply it by the last guy. So those two make a +1x, or we'll just put x. And then you end up with this so far. So I always think it's easier when you go to multiply the next step to think about the smaller of the two. And so this binomial has two things in it that need to be distributed basically back to the other three. So one way of looking at it is like this. Take the x and multiply him by each of the 3 terms in the first polynomial, and then multiply 3 by each of the terms in the first polynomial. And it's like a double distributive property. You do it once with the x and once with a, make sure you think of that as a -3. So first we're going to take the x and multiply it by each one. We're just kind of looking at distributive property backwards. So x to the third is x times x squared, plus x times x is x squared, and x times -2 would be -2x. Then we just keep going right next to that and say -3 times our first term is -3x to the second. Then -3 times our second term is -3x. And then -3 times our third term is -3 times -2, which is +6. Then you look for any like terms again, and I see one here with one here, and I see one here and one here. So we're going to put those together. Start with our x cubed, and then when we put the two x squareds together, we have a 1x squared and a negative 3x squared, so that gives us a negative 2x squared. Then when we put our two x's together, we have negative 2x, negative 3x, which is negative 5x. And then we bring down our plus 6 at the end. So remember there was a y in front of this each time, so we probably should carry that down to each step along the way. And then our final polynomial function is right here, and that is considered standard form. You have written it from the highest power down to the lowest power of x, and it's all in order, and there's no parentheses, so that is standard form. I wanted to show you one other way that you could set up that last multiplication that you were required to do. Some people really like to set it up this way, and I like it because it's not as confusing as all those arrows and lines and circles. And so try this if you'd like. What I do is I take the x and put it in front of that polynomial that you're going to multiply it by. And then you take the negative 3 and put it in front of the same polynomial again. And that just represents the two steps that we did before. But what we're going to do is we're going to distribute them off to the side, and then whatever we get over here, we're going to add all our like terms into one big polynomial. Another thing about this method is usually the like terms are kind of at a little bit of a diagonal to each other, and I'll circle all the like terms, and they usually line up that way, and then just don't forget about the first and the last term. So basically we get x cubed. This one ends up being minus 2x squared. This one ends up being negative 5x, and then plus the 6. That's just a more organized way of doing it, and if you like that method, I would use it.